We would like to introduce to you the CKFLUIDSOFT chemistry module, its capability, and how to use it inside a CFD environment. In the chemistry modules, species and reactions could be introduced through the keyboard or by reading a number of files. So they could be CKFLUID files, or we can also read ChemKin, Cantera, and begin and end types of files. All those files are just text files with these very common extensions. The CKFLUIDSOFT files could be binary files that have been previously saved by CKFLUIDSOFT itself. The software also includes a number of physical properties, which are transport types and then thermodynamic types of properties. The species inside the CKFLUIDSOFT are basically molecules. Molecules which are a combination of atoms, and the atoms are being named by following a standard chemistry fashion, where the first letter is an uppercase letter followed by a possible lowercase letter, such as sodium, nitrogen, and so on. And then the elements of the species could also be some charged components, such as the ones used inside electrolytic reactions. The type of reactions is just a general type of reaction with any number of reactants and any number of products. They could be elementary types of catalytic reactions where there is a site particle taking directly part into the reaction, or they could be global types of reaction with the catalytic site not appearing inside the reaction stoichiometry. They could also be electrolytic types where there are charged particles and the presence of electrons. So it could also be homogeneous type of reactions or any other types that the user may define by himself. The CKFLUIDSOFT computes SUS terms, and then one of the main values used in the SUS term is the rate of reaction. So the rate of reaction, the type of rate of reaction that is built in the CKFLUIDSOFT is an Arrhenius power law types of formula, such as the one which is displayed, where the user is then supposed to define the parameters as well as the powers of each concentration. And then the user has a possibility of supplying his own user parameters or updating or changing the parameters at runtime. And in any of these cases, the parameters or the formula itself could be any valid math expression that the user may think about. So for the physical properties that we said earlier, so there are more than 20,000 data for species, and then those are transport type and thermodynamic types of data. As far as transport types of data are concerned, we have CP, conductivity, viscosity. They are supplied in form of polynomials with up to 7 coefficients. And then there is also the diffusivity, which is then used to compute diffusion. The type of formula which is built in is a Fuller types formula, where there is the presence of diffusion volume and then the molar mass. In all these cases, the user may define his own data and supply a user-defined transport property. The thermodynamic data which are included are just entropy and enthalpies of different process, and as well as the density of dense phase. The density is then supplied in form of polynomial as well. So once all the data are supplied and all the reactions are supplied, what is it that the CKFLUIDSOFT can do? Once it's supplied, the CKFLUID software will then go collect all the species from reactions and all the species that are defined outside of the reaction, and then list them. And then at the same time, the CKFLUIDSOFT could also balance the stoichiometry if the user requests it. And then once that is done, the CKFLUIDSOFT will then create a dynamic library, link library, which then contains all the physical properties and all the thermodynamic properties that have been collected from the user and from the database. So that DLL could be a 32-bit or a 64-bit, depending on the type of OS being used. So that DLL could then be used to compute the source terms, the rates, and then using other parameters that the user may supply at runtime. So the type of OS could be Windows or Linux or Mac OS. So that's all that it takes. So basically what happens here is that all the data that the user supplies are now compiled and then stored inside a DLL that the user can use to then hook up with other programs. So once the DLL is produced, a number of files are also produced to help the user learn how to hook up the dynamic link library with other programs. So those data which are in the DLL could then be used in any CFD software. So there are a number of files which are produced to be used as test case so that the user may learn how to hook them with any other program, which could be C, C++, Fortran, MATLAB, or Java, or any CFD software that the user possesses. So the ChemTest file are just test cases that demonstrate how to hook up the chemistry with other programs. The ChemSource.c and the .c here, they are just a bridge between the ChemTest, the user or the CFD, and then the DLL itself. So the ChemSource is a bridge between the two. The ChemTest is just a file that shows how to call the DLL by using this ChemSource file. So this bridge file is only important for Fortran or C or C++. When we deal with MATLAB, so this is the ChemTest, and the bridge which is used to hook up and connect with MATLAB here is just the jar file, which is a Java file, or it's just a zip file that contains Java files, which is a jar file. So when we run or look at the ChemTest in MATLAB, one can see how to use the DLL inside MATLAB. So there is also a test case that is provided for Java, so we can just run it by running java-jar, and then the ChemTest, which is included in Java, will be run, and the user may see how to hook it up with Java as well. So that's everything that's then produced after the user supplies the data and then clicks on a button to produce this data. So it's very easy, it's very user-friendly, and then we hope that it will help you to use the CKFLUIDSOFT. In this chemistry demo, we're just going to show how to supply the rates and then to supply the stoichiometry of reactions inside the CKFLUIDSOFT program. So these are a list of reactions that we will then just show how the user may supply them inside the software. So once we start, we obtain this window here. We select the first point, and then we supply the directory where we want our data to be stored. This window is then produced. It's self-explaining. This box is for inert or species that are defined outside of the reaction. We supply the size symbol, and then from here we supply any symbol for the particulate. And then in this box here, we click within this table to then start to supply the rate of reactions, so the stoichiometry of reaction. In the same time, one can also import it by reading from a file if we would click on import. So once that is done, once we click on this button here, we get this following window where we supply the stoichiometry for the reaction. So this is the first one for the methane. Once we click here, we supply it, and then that's how it's introduced. Then we do it for all of these reactions that have been listed. So after we supply all the reactions, we get the following table here. So for the sake of the demo, we just put zeros for the site reactions. So we have an inert species, which is nitrogen, and then we have a site symbol, which is platinum, which correspond to these two reactions. So by placing platinum here, we want to tell the software that PT is not just any species, but it's a site, so that will be treated like a site symbol here. So these three species then correspond to a site of PT. So then after we click on update, all the species in the reactions are then collected, including those that are listed inside these two boxes. So they are then collected, so we have 9 species. So the species collected are then being used at the same time to go and then read into the database. So these are the number or the list of species as they have been read from the database. So these are the species as well. These data from the database could be updated, they could be overwritten, or they can be used just as they are. So once we click on compile, or once we click on compute chem, these two buttons, then the software creates a number of files. So those files, which are the files that we spoke about earlier. So it mainly creates a 32-bit file, because it has been performed and run under 32-bit Windows XP, and then a number of test case files that could be used. So here we have jar file, Java, and the 32-bit DLL, and then the chem source, which is a bridge that's used inside for the case of Fortran or C and C++. The jar file is used as a bridge to connect with the DLL in case of MATLAB and the Java. So, and then once we do that, we can run the test chem, which is just a test case that would run the DLL and then display the data which are contained inside the DLL. So this is a user-friendly routine that could be used to display the information which is already contained inside our DLL here. So once that is done, we then just run the chem test under MATLAB, because we have MATLAB here, and then we run it, and then after we run it, we then will see the data which are contained inside. So this is a MATLAB where we run a chem test, and then we obtain this information here. So we see the net rate for the two reactions are 0, because we didn't supply the rate constant, we just set them to 0. And then the net rate for the first two reactions are supplied here. So the values that we obtain here are randomly computed. They are randomly computed from any OS to another one. So the user may test it by forcing them to be specific values. So the chem test from MATLAB could be opened and read. The user can investigate it and see how to hook it or use it into another CFD program or MATLAB program. The chem test, the 3 chem tests, they show how to hook up the chemistry software with other software which are made or built in Fortran or C, C++. So the 3, they show them. The chemistry Java also shows how to hook up a chemistry module with a Java program. So that's what it takes. We thank you for your interest in using CKFLUIDSOFT. It's very user-friendly, and we hope that this information will help you to hook it up with other program or CFD program. Thanks a lot.